Hey everyone, in this lesson we're going to be talking about adding and subtracting rational expressions. So let's take a look at how we go about that. We always want to try to make things more simple, so that's a good reason why to do this. So we're going to start off with just regular fractions before we move into actually rational expressions. So the first step we want to do is we want to find the LCD. Now, LCD stands for least common denominator. So the smallest number that both of your denominators go into is your LCD. Then we're going to multiply so that we can have that same number in the denominator of both fractions. Then we're going to add or subtract, depending on what we're doing, the numerators. And make sure to just keep the denominator. Okay, you're not going to change that. You've already done that work. Okay, and then we'll simplify if we can. So let's take a look at some examples here. So here's two examples for us. So if you look at the first fraction set, you've got 7 and 10 as your denominators. And the least common denominator between 7 and 10, well, look at the numbers that multiples of 7. You're not going to find one that 10 goes into until you get to 70. So how do I go from 7 to 70? I've multiplied by 10, which I'm going to do to the same, I'm going to do to the numerator as well. So now I have 30 over 70. And then here I've multiplied by 7 over 7 to get 21 over 70. And then I'm going to add. And when I add those, I get 51 over 70, and that does not simplify. Now, the second set of fractions, we've got 6 and 3. And the LCD between those two is actually 6, right? Because 3 multiplies by 2 to get to 6. So because 6 is my LCD, I don't actually have to change the denominator of my first fraction. All right, I only have to change my second fraction. And 13 6 minus 4 6 is going to get me 9 6, but that reduces because 9 and 6 are both divisible by 3 to get me 3 halves. So that's working with fractions, right? So let's talk a little bit about finding LCDs of a rational expression. So we definitely start with our numbers, okay? And we want to look at each factor, individually. All right, factors are separated by multiplication, not by addition or subtraction. So when we look at the numbers, okay, we just find the LCD just like normal. Okay, that's not a problem. When we start to look at variables, when we're dealing with monomials, okay, monomial meaning one term, okay, you find the LCD of the variable by taking the highest, sorry, things keep moving, taking the highest degree of the variable. So the LCD between like x squared and x to the fifth, it's going to be x to the fifth. Okay, you can multiply x squared by x cubed to get to x to the fifth. Okay, and then when we're dealing with binomials or higher, okay, you're just going to take the highest degree um, of the factor found in the expression. All right, so let's take a look at some examples of that. So if I wanted to find the LCD between 3x squared and 4x, well, 3 and 4, look at their multiples. The smallest multiple between the two is 12, so that's going to be the number part. And then you've got x squared and x to the fourth. Well, x to the fourth is higher, so you take the higher degree, and there's the LCD. But if you were working with a set of binomials like this, all right, again, look at your numbers first, 3 and 8. The smallest number that both multiply into is 24. Okay, and then you've got x plus 2 squared and x plus 2 squared. Well, what's the higher of the same thing? The same thing. So you're going to have 24 times x plus 2 squared. All right, so I'm going to skip ahead because in class we'll do dry erase break. But then coming back here, let's do some more practice. Now with fractions, dealing with a denominator that's a monomial. So again, we find our LCD first. So if you look here, you've got a 2 and a 1. So LCD is 2 there. And then you've got an x and an x squared. So x squared is your LCD, 2x squared. So to change this first fraction, we have to change the 2x into a 2x squared. We do that by multiplying by x over x. So now I have 3x over 2x squared. For my second fraction, I'm just missing the 2. So I get 8 over 2x squared. So I've multiplied, I've changed my fractions, and now I'm going to add my numerator. So 3x plus 8. Well, they're not like terms, so I have to keep them separate. And then the 2x squared just comes along for the ride, and that's done. All right, here's another one. So our LCD between 3 and 5 is 15, and between x and x to the 5th is x to the 5th. So my first fraction has to be multiplied by 5x to the 4th to get to my LCD. So my numerator becomes 5x to the 4th, and my denominator is now 15x to the 5th. My second fraction just has to be multiplied by 3 over 3. So now I have what I wanted. And now I'm subtracting. So it'll be 5x to the 4th minus 12 over 15x to the 5th. And that's as far as I could go since they're not like terms. So now let's talk about what happens when we have something bigger than monomials, like binomials. Okay, so definitely make sure that you factor. So the LCD. Okay, the LCD is the combination of all possible factors with their highest power. That's an important definition. So like if you look at these two problems, right, x squared minus x minus 12 factors to x minus 4 and x plus 3. And then the factors for 3x minus 12, you can just take out the GCF and you have 3 times x minus 4. So my LCD between these two, well, x minus 4, x minus 4. We write it down. Another factor is x plus 3. There's nothing over here for that, so we write it down. Then we technically have a 1 out front and a 3, so 3 has to be part of the LCD. So that's my full LCD there. So let's take a look at some steps here for when we're adding and subtracting rational expressions. So first thing you want to do, factor the denominators. Okay. Then you're going to find the LCD. Okay, then you're going to rewrite the fractions with the LCD. You're going to add and subtract, or subtract I should say, the numerators. Remember, we are keeping our denominators. And then we'll distribute. We might have to factor, we might have to cross out, we might have to just combine like terms, right? There's lots that are that goes on here in this last bit. Our goal is to make it as simple as possible. All right, so let's take a look at this example. Now we've already factored this. I did that on the slide, 2 slides previously. So we get x minus 4x plus 3. So my LCD, remember, combination of all my possible factors, and that would be 3, x minus 4, and x plus 3. So my first fraction, if you look at this compared to the LCD, the only thing I'm missing is the 3. So that's what I have to multiply by in my numerator. Now don't forget, okay, to distribute that because my numerator is a binomial. So I've got 9x plus 3 in my numerator all over my LCD. Sometimes I get a little lazy and just write LCD. So for my second fraction, notice we're missing the x plus 3. So that's what we have to multiply by in our numerator and denominator. Again, distribute. So we're going to have 5x plus 15 over the LCD. Now we're ready to subtract because it's a subtraction problem. So don't forget to distribute that subtraction sign through. So if I rewrote the whole thing, it'd be 9x plus 3 minus 5x minus 15 over my LCD. Okay, so let's combine any like terms. So 9x minus 5x is 4x, and 3 minus 15, that's going to be minus 12, all over. And now I'm going to actually write back in my LCD, which is 3x minus 4 and x plus 3. Okay, then I'm going to see, does anything factor or anything cross out? So the numerator, there actually is a GCF of 4. But that does not cause anything to cancel out. So either of these answers would be perfectly fine. Okay, so for my next one, let's make sure we factor our denominators. My denominator, my second fraction, is a difference of squares. So my LCD, combination of all my possible factors, it's going to be x plus 1 and x minus 1. So my first fraction is missing the x plus 1. So that's what I'm going to multiply my numerator and my denominator by. So my first fraction becomes x squared plus x over the LCD. And my second fraction doesn't have to change at all. So 3x over the LCD. So my numerator is now going to be x squared plus 4x over x plus 1 and x minus 1. Well, my numerator does factor, and then we get x plus 4 and x, but again, nothing's going to cross out. So either this answer or this answer is fine. All right, and then here's two more. Feel free to pause and try on your own and then press play when you're ready. So my denominator of my second problem factors to x times x plus 2. So my LCD is actually going to be x times x plus 2. So my first fraction just has to be multiplied by x. So I get 2x squared over my LCD. And then I have minus, my second fraction doesn't change at all. So I've got 2x squared minus 8 over x times x plus 2. Now my numerator, I can take out the GCF and get x squared minus 4, and then I can actually go a little bit further and do that difference of squares. So I get x plus 2, x minus 2. And remember that this is all over my LCD, which is x times x plus 2. So I can cross out the x plus 2's. So final answer, 2 times x minus 2 over x. All right, and then our final problem, we've got a difference of squares here, so x plus 2, x minus 2. My LCD is going to be x plus 2, x minus 2. So my first fraction doesn't have to change at all. Okay, my second fraction is going to change though. So sorry, made a little mistake here when I was writing. So I'm going to write LCD. My second fraction has to be multiplied by x plus 2. Make sure to distribute the 7 through. So 7x plus 14. And then again over my LCD. So now I'm subtracting. Make sure you distribute that minus sign. So 5x minus 7x is negative 2x. And then nothing minus 14 is going to be minus 14 over my LCD, which is x plus 2, x minus 2. The only thing I can do there, I can factor out a negative 2, leaving me with x plus 7, but nothing crosses out. So again, either answer would be acceptable. And that is adding and subtracting rational expressions.